Hi, and welcome to a lecture in the series of lectures on C# programming.
The sun has got his hat on, hip 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 hooray! The sun has got his hat on and he's coming out today.
And yes, you've guessed it, it's about arrays.net. And I, of course, am your presenter, Dr. Peter O'Neill. Okay, purpose. Most programs process sequences, lists of data. For example, lists of names in a database, lists of files in a folder, lists, collections of bytes on an MP3 file, the text within a web page. Arrays, lists, these collections are quite similar to each other. Each tend to support the following operations. Create a new array. Insert an item into an array, e.g. insert item at the end of an array or insert into a new item in the position 37. Amend an existing item. In other words, basically change the location 32 to Mike. Delete an item. So that means basically change it to nothing or to a blank or whatever. Recall an item. So we can use the data that's contained within the array. So get the item stored at 27 and place it into the variable x. At runtime only these are. Arrays are not a component and therefore do not appear in your toolbox. They are created within the code and stored within RAM, random access memory. This means that they can be accessed extremely quickly. An element will take 1 microsecond to access. So let's look at some code. Here is an array of integers. It's got 6 elements of integer type, and it's called house. Here we are. So in our minds, if you like, this is how we would create it in our mind. So it's a one-dimensional array. So this is naught location, or the offset of naught. This is the offset of 1, 2, 3, 4, 5. And that's as far as we go, because it's got 6 elements in it. We started at 0. Okay, now put 6 in, but we'll not be using it. We can assign a value as follows. So house, so 300 at house offset 2, or element 2, will equal 300. And here we are, offset 2 equals 300. House offset 5 will equal 0. In the previous slide, I declared integers, but you can declare an array of any type. So for example, here's an array of char. Char is a character, a single character. It has 4 elements. So here's our example again, created in random, our representation for our minds. And as you can see, we've got them numbered down the side. And if we wish to, we can put name, offset of 0 becomes P. There's offset of 0, which is actually name if you think about it. And it's become P. Then we can say name at offset of 1 becomes E. There's offset at 1 of name, and it becomes E. Name offset at 2 becomes T. There's 2, there's a T. Name 3, offset at 3 becomes E. There's 3, it becomes E. And finally, name at offset of 4 becomes R. Offset of 4, R. And you can see that in Code Project examples, arrays off Blackboard. But what if we want to assign an element outside the boundary? So here's our representation again. And it's names at offset 5, which doesn't exist because we only declared 4. And the actual code will complain profusely. And that's because no elements are available, and it was declared with only 4 elements, and an exception is risen. So it'll say index out of range exception because it's outside of the bounds. Now you can capture those and actually change what it says. So you can change it to what you want it to say. These are particularly important when we're writing software where we give the user the ability to put the information in, that we validate what they've put in to ensure it does comply with what we expect and what we require. So if it doesn't, then we definitely need to write our code to capture that and report it back to the user and ask them for it again, or ask them to change the details. Therefore, validation is important, particularly if you're going to determine the attribute's location within an array. In addition, note that each element in the array is a variable in itself. It is not possible to perform operations on old arrays with one statement. Therefore, we create methods to do a task. Well, what do I mean by that? Well, say for example, I want to initialize an array of zeros. Then I would use a loop and go around each element of that array and set them all to 0. And that would have to be written into a method in order to enable that to happen. You couldn't just say, set them all to 0. But before that, what does this remind you of? Looks familiar. I know it's my name. Give you a clue. String. Name. That's right. Basically, char, array, is actually a string. And that's how we make up strings. So strings are made up of an array of char. First, let's create a user interface to contain some buttons and some text boxes. So here we are, we're going to create an array, and we've created a text box multiple lined and 3 buttons. And you can see this on project examples arrays number 1. Remember, you need to set the scroll bar to both and the multiple lines to true, as shown here. So there's both scroll bars, there's multiple lines, both set to the relative settings. Otherwise, of course, the text box will not let you make it more than a single line, or not let you see what's actually written in the text box on the secondary line if you don't include scroll bars. So what's behind each of these buttons in turn? Well, let's go for quit. That's dead easy. Yep, you've got it. Close. So all it does is close the actual app. Okay. Display. Right, so in display, we know how many turns we're going round if we've declared an array already. So it's actually going to be 10 by 10. I've also noticed an error here. Yep, and that is I plus plus should actually be place plus plus. So we open our squiggly brackets. Remember, this would be in a method. And then we say display text box dot append text open brackets place plus space plus a place plus new line. And that basically will write or present whatever is in our array into our text box, because it will go around there and it will put each one on a new line. So it will say place and then whatever number's in place followed by a new line. By the way, notice new line is in less than, greater than, and the reason why is it should have environment dot new line, but there wasn't enough room to get it on the slide. Okay, so don't forget that. So it's environment dot new line. So in place, what happens is it comes in, it sets place to 0, it sets place to 0, and then it says, right, let's go in. It reads the element of place and it writes it into, appends it to the end. So it puts text in, then a space, then another adds, and then a place. Note A is our array, place is our offset. So in this case at first it's place at offset of 0, and then it adds a new line as well. And then it goes back and does it all over again. So what's now behind the enter button, the last button? Okay, so we've got for I equals 0, I less than equal to 9, I plus plus. Then we open our squiggly brackets. Again, this could be put into a method. So we can just call it, I'll possibly call this method populate array, for example. So here we are, look, we've got a open squared brackets I, close squared brackets. So that means populate A at the offset of I, whatever becomes from the input of the user. So the user can put numbers in and it will locate them into A at the offset of I. So basically, this will ask you for 10 numbers. And that's what the bit enter item says. Enter item 1, because I or 0 in the first instance, and it converts to a string, and it asks you that. So the user will be asked to enter up to 10 numbers. Don't go around. So let's represent that so we can see it. So A is an address in memory, and in the first instance we enter 55, enter item 0, and we enter 55, and there 55 goes in the offset of 0 in A. Then we enter 126, and that goes in the offset of 1. There it goes. Then we enter a 1 at the offset of 2. Then we enter 12 at the offset of 3. And then 4, and so on. Okay? And it will go right round to 10. And you can see that in arrays examples number 1. Again, available to you on Blackboard. I'm not going to cover reversing, searching, largest. You can do all them in your tutorial sessions. Arrays as parameters or arguments. So int sum array. So here we've got a method called int sum. So it returns an integer, and then we're passing to it int an array of A. Now notice we're telling it the type, and our open and close brackets with no number in it means send the complete array, and this is what the array is called in this method. Now it could be different to what it's called in the main method. Okay? So you can change it. Note the open square brackets and close square brackets contain no value because we want it to send all of the values. Int total equals 0. For n equals 0, n less than equal to dot length minus 1. So we're counting how many elements are in the array. And then we're minusing it by 1 to get the last element. And we're going to start at the 0 element and work his way through to the last element. So we're opening squiggly brackets. And as I say, this is a part that works out how long our array is so we can get from the beginning to the end. So this gives us the end element. Okay, so we restrict it. Okay, so we can then say total will equal total plus A, and that should be squared brackets, not rounded brackets, n close squared brackets. semicolon. So we will add each of those numbers that we've previously put in, and we'll add it to total. So we initialize total to begin with as 0, and then we say that total equals total, so 0 equals 0 plus the first number that put in. And then it'll equal whatever that first number was, whatever it is, and then adds the next number onto it, and so on. And that again will be put into a method. And the method would be some array. And we're sending it to it. So we can build little methods to do tasks on our array that we want. And then eventually we return total. And that's why int sum of, or total sum. So the method returned an integer, and that's what total is. And you can see that in arrays examples number 2. Okay, so let's have a quick look at two-dimensional arrays. Now, can we think of something that gives us a perfect two-dimensional array? I can straight away, and that's right, it's a chest or dashboard. Because this is a one-dimensional array, so is this. So is this. However, the whole thing is a two-dimensional array. Question: how many arrays are there when you count each array only once in the following image? I'll give you a little bit of time to look at that. Or if you like, press pause, count them, and then turn it back on. So how many do you think there are? Well, let's have a look. There are 9 one two-dimensional array and 8 one-dimensional array. So there are 9 one two-dimensional array and 8 one-dimensional array. Well, how did I get to that? Well, here we are. Let's have a look at our board again. There we are. That's our two-dimensional array. So we can't count them again. So where the hell's our one-dimensional arrays? Well, what about the ladders? 1, 2, 3, 4, 5, 6, 7, 8. Plus the two-dimensional array is 9. Declaring a two-dimensional array. So I'm going to create as a checkerboard, and it's going to be made up of Boolean. Boolean is either true or false. Sometimes Boolean can be represented also by 1 and 0. So we've got Boolean as the type, and we've got open square brackets, comma, closed square brackets. So that's telling me that we're going to have 2 numbers inside them square brackets. That declares to the machine, this is a two-dimensional array. And its name is checkerboard. And it is instantiated when we call this line in its entirety. Because we say new Boolean 8 by 8. Basically, we're creating a checkerboard just like we just looked at. So the comma declares the fact that it is a two-dimensional instead of a single-dimensional. Had there been no comma there, then the machine would assume only one number would be entered, which is a one-dimensional array. And this is our size of our array. Okay? So the maximum rows and the maximum columns, I always look at them that way. What type of loop are we going to be able to use? Well, I've just said we know how many turns they're going to take. So we know it's a for loop because we know how many times we're going to go around. It's a deterministic loop, not a non-deterministic loop. So here's our example of our deterministic loop, because we know how many they're going to be. So for int row equals 0, row less than equal to 7, row plus plus. So there are going to be 8 rows starting at 0 and working to number 7. And in each row, there's going to be one column. In fact, there's going to be 8 columns in each row. And hence we get our board. So these two for loops create our two-dimensional array. The content within the for loops, from if down to the closed squiggly brackets on if, yeah, that determines what's going to populate each of the cells. And you can see that in examples array 3. Basically what I've made it do by using for and a little bit of mathematics and thought, I've made it do black, white, black, white, black, white, black, white, black, white, and then opposite. So each time it goes down, it looks at the previous one above and says, are you black or are you white? And depending on which one it is, the opposite is true. So it starts off with the other one on the next line down. Okay. So let's try and display that in the text box so we can see that we've done it correctly. Because I set the array as Boolean, I will need to convert them, and I've chosen to use 1 for true and false is 0 in the actual image. Otherwise, what we'd end up with is we'd end up with the word true, 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 false, true, false, true, false, true, false, which goes right across the page, and I didn't want to do that. So basically, I'm now saying to if you see this as true, print a 1. If you see this as false, print a 0. And at the end of every 8th character, we need to tell it to start a new line. So otherwise we'd end up with a great big line of them. So here's the code that outputs it. As you can see, we've got our for loop for row and our for loop for column again. And this time all we're doing is we're looking at checkerboard and saying if checkerboard at row column equals true, and if column equals 7, then print a 1 plus new line. Else, just print 1. And then we've got else, if column equals 7 again, then print 0, new line. Else, just print a 0. So it's quite simple, the if statement. One deals with the 1s, and the else deals with the 0s. Yeah, so if it's not true, it goes to else. If it is true, it goes to 1s. And you can see that again in arrays number 3, available to you via Blackboard. And this is what it produces. Says, yeah. Now, admittedly, it doesn't look square. It's more of a rectangle than a square. but that's just because the sizing of our text is taller than it is wide. So we could change that. And one of the things we could do with this, for example, would be to send it to our GUI image array and have it replace the numbers with pictures instead. So we could have a black square, white square, black square, white square, black square, white square, black square, white square, square is hard to say that, and then move to the next line and do the opposite again. So each of these would represent a single square, each number. So key points. Array elements exist in RAM and can be manipulated just like any other variables. An individual element is selected by a script or a little bit of code. An individual element of the array is selected by a subscript, or I call it an offset. So it's an offset of the actual variable. And this is expressed in open brackets, square brackets, and closed square brackets. Recall the expression includes a number, a variable, and calculations. To perform the same operation on each element of an array, we often use for, and we step through each of them in turn. We use for in arrays basically because they are static arrays, and therefore it's deterministic. We know how many times we're going to go round, therefore we use a for loop. We could use a do while, we could also use a while, but we tend to use a for loop. Any questions? Please come and see me in your tutorial session, or please feel free to email me with any of your questions, and I will endeavour to answer them. Thank you for your time, and I trust that you've enjoyed the video, and I look forward to speaking to you again in the near future.